Space, the final frontier. These are the voyages of the starship Enterprise. Its 5-year mission, to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before.
Captain's log, stardate -52-1. After a run-in with some very dangerous pirates, we have received new orders from Starfleet Command. We have gone back in time in order to educate the generations of teens in what they call year 2014. Our mission is to...
Captain! You don't need to update your log. I'm right here.
Yes. Mr. Scott?
Yes, Captain. I nearly have the demos set up.
What was that?
Romulans, they beamed up half our fuel supply. With the ship in this shape, we'll never be able to defend ourselves.
Can you not make more?
Are you mad? It takes hours for the fuel to react.
On the contrary, I can do it in a matter of seconds.
Spock, that's impossible.
No, Captain, it's not. You see, every reaction has a rate of chemical process. Much of this rate is determined by the potential barrier that blocks the change in states of matter. Much of this rate is determined by the potential energy barrier that blocks the change between two molecular or atomic states. You see, when the barrier is low, the reaction can happen relatively quickly due to the small amount of energy necessary to surpass it. However, when the barrier is high, then only high amounts of energy can surpass it. Therefore, the reaction happens slowly. This potential energy barrier is the required amount of energy necessary to start a reaction.
Are you trying to tell me we're going to die because the fuel reaction has a high potential barrier?
No, I'm trying to explain how I'm going to save us. What we need to do is speed up the rate of the reaction.
Yes. By doing that, we would be able to speed up the rate at which the products are formed.
That means we'll be able to make the fuel before the Romulans blow us to pieces.
Ah! Hurry, Spock! Holy sacred Quinto! Well, there are several factors that can speed up a reaction.
Right, like the concentration of reactants, the temperature, and the presence of catalysts. Increasing these will change how fast the reaction goes.
So the higher the concentration, the faster the reaction goes. Right, the higher the temperature, the faster the reaction.
And finally, catalysts will help a reaction along without changing the equation itself.
So the higher the concentration, the faster the reaction goes. Scotty, get the lights.
As you can see, a very small amount of this glowing substance does not glow very much, but if you add a lot, it glows a lot brighter. The more concentrated the substance is, the faster and more violently it will react.
Amazing!
Right, and the higher the temperature, the faster the reaction. This is cold water, this is room temperature, and this is hot enough to boil your face off. The fuel cell in the hottest cup glows brighter than that in the room temperature or in the one with freezing water. This clearly shows how heat speeds up a reaction.
And finally, catalysts will help a reaction along without changing the equation itself.
I can't see anything. Scotty, turn on the lights.
Now, this can be dangerous without protective materials, but I can show you a video on my tricorder. In this beaker, a reaction is happening, but so slowly you can't see it. That's a catalyst. Adding it will speed up the reaction.
Now that it's been added, you can see the reaction clearly.
If we use a catalyst, Mr. Scott will be able to speed up the reaction of the fuel.
All we need to do is add enough energy to get the atoms into an active state. Great, so all we need to do is bring down a space heater to the reactor core. No. Also, you forgot about the order of reaction. The what?
Of course. You see, Captain, the order of reaction has to do with the sum of all the exponents in the reaction on the reactant side. For example, H2 plus O2 yields H2O. H2 and O2 are both second order, and the reaction as a whole is a fourth order. This too can affect the rate of reaction, and we need to take it into account if we want the chance of getting out of here alive.
Then get to it, Mr. Scott. Kirk to bridge, can you hear me?
Loud and clear, Captain Kirk, sir.
Now, when I give the word, have us pull out of here at warp speed. Wait for my signal. Captain, I don't think that's the best idea. Don't get your pointed ears in a twist. Mr. Scott, status?
It's just as the Vulcan said, fuel in seconds, not hours.
As I told you, it's just simple chemistry. Check out now!
Oh, great job, lad. I had my doubts, but you pulled through.
It is by no count my victory, and I am not a lad. By increasing the concentration of heat, adding catalysts, and utilizing the order of reaction, any reaction will have the same results. It's just simple chemistry.
Simple chemistry? Are you out of your Vulcan mind?